Okay, so today our goal is to use all the skills that we have learned in the polynomials unit, right? All the skills, so that means your synthetic division. If you want to use long division, that's fine. Our knowledge on factoring, or if it's not factorable, we're going to use quadratic formula. So we're going to use all of these skills to find all of the zeros of the given polynomial, real and complex. Right? So that means if the polynomial is degree 4, we know based on the fundamental theorem of algebra that the number of total zeros is going to be 4. Okay? Maybe some of those will be real, but some of those can be imaginary or irrational or complex roots. Okay? All right. So let's review first the factoring method. If the polynomial is factorable, we're going to do the factoring method, right? So let's review. Find all the zeros of f of x equals x cubed plus x squared minus 16x minus 16. Okay, and we know that this is a 4-term polynomial, right? And what is the degree of the polynomial? Degree 3. So we know that based on the fundamental theorem of algebra, we know that we will have 3 zeros, right? Total of 3 zeros. It can be complex or imaginary. Okay, but how do we factor this? If it's a 4-term polynomial. Yes, we're going to group this. Also, if you want me to show the work from the quiz, the last question, the quiz, since everybody's done with the quiz, I can show that if you want me to. Okay, maybe later. Okay, so we can group this, and then, right? This is going to be our first group. That's going to be the second group. And then we're going to factor each group, right? So what's the greatest common factor of x cubed and x squared? X squared. And then so I can divide this by x squared. So that's just x plus 1. Right? And what is the greatest common factor of negative 16x and negative 16? Negative 16. And then, so we're going to divide that by negative 16, which is also x plus 1. Okay. And then I can combine the outer factors. So x squared minus 16. And then the common factor, x plus 1, we're going to write it as one factor. Right? So x squared minus 16 times x plus 1. Okay. And so our polynomial, I'll just write, oh, sorry, that's f of x. So we'll use the notation. So that is f of x equals, and then just copy all the factors. Yes, we can simplify x squared minus 16, right? Right, because this is a difference of 2 squares, right? We just have to take the square root of the first and the second, and we do plus and minus, right? Remember that? So that's a difference of 2 squares. So that's x plus 4, x minus 4, remember? And then the last factor is x plus 4. Okay, so we now have all the factors, but we need to solve for the 0. So we just have to set each factors to 0 and then solve for x, right? So that's x plus 4 equals 0. And we know that x is going to be negative 4 if we subtract by 4 on both sides. X minus 4 equals 0. And so we know x equals 4. And then x plus 1 equals 0. And we know that x equals negative 1. Okay? So as you can see, we have 3 zeros, right? 3 zeros or roots. Okay. All right. Any question with this? Any question? Okay. So now we're going to try to do what if you have a sum or difference of 2 cubes. We know that if you have a difference of 2 squares, we can do these when you factor the difference of 2 squares. But again, the same as the 3.0, the lesson 3.0 factoring techniques, this is the form when we factor the sum and difference of 2 cubes. Okay? So just think of this as if you have a cubed plus b cubed, meaning the operation is addition, the first factor is just the cube root of this. And then just copy whatever's the sign. So if it's positive, then just do a plus b. Right? Because cube root of a cube is a, cube root of b cube is just b. And then the second factor will just be based on if you have already this answer, your first factor. So this is just the square of the first, and this is the product of A and B, but you have to switch the sign, right? I can just write this as SOP, right? For the signs, right? So when you say S, this one is always going to be the same sign as whatever's the sign there. And then opposite sign, that's O. And P, because the last term will always be positive, right? Because if you multiply positive times positive, negative times negative, it's always going to be positive, right? So same sign, opposite sign, positive sign. So same thing as this, same sign, opposite sign, because if this is a minus of the difference of two cubes, this is a minus, then this is going to be plus, opposite sign. And again, the last one is always positive. Okay, but you take the square of the second term for the last term in your factor.
What if it's missing a value?
Missing, what do you mean missing a value?
If there's no AB.
If there's no AB. So basically, this is just the pattern when we try to factor a difference or sum of two cubes. It's not going to be missing.
Okay, what if it's missing? So it can be missing.
That means that it will not give you a difference or a sum of two cubes. Okay? So remember, let's say, for example, if you have x cubed plus 1. X cubed plus 1 is a sum of two cubes. 1 is a cube, right? You can do 1 raised to the power of 3, and x is also a cube, right? But how do you factor out this? Or how will you get this? It's just going to be x plus 1 times, right? X plus 1. Hold on. And then I'm just going to write this. X squared minus 2x, or sorry, minus x plus 1. Okay, why is it x squared minus x plus 1? So I'm just showing that basically we will have a middle term. It's just the product of the first and second. So x times 1 is x. And then opposite sign, so that's why it's negative x. Okay? And we can factor this as, can we factor out this x squared minus x plus 1? No, so we have to use a quadratic formula here. But then, again, if you multiply this x plus 1 times this, it's going to give you that. That's why I'm showing the form, right? Because this is just working backwards. We got the factors. If you multiply the factors using FOIL, it's going to give you that. But if we have the polynomial and we're asked to factor, then that's how we do it, okay? All right, so we're going to find all the zeros for the polynomial function f of x equals x cubed plus 64. So this is a sum of two cubes, right? Okay, so I'm just going to write x cubed plus 64. Okay, so the first thing that we have to do is we take the cube roots of the first and the second so that we know our a and b, right? So a is just the cube root of x cubed. I'm just showing this part so we know what to do, but you don't have to, right? I'm just showing this part. So we know our a is just your x, right? So I can equal up that to x, right? And then your b is the cube root of 64. What is the cube root of 64? 4. That's 4 times 4, then times 4. 4 times 4 is 16, times 4 is 64. So therefore, your b is positive 4. Right? So x plus 4. That's going to be your first factor, a plus b. But then the second factor will just be, so your first term of your second factor is just the square of the first term. So that's your x squared. And then the second term will be the product of a and b. We know a and b is x and 4. But then you have to take the opposite sign. So minus 4x. Okay, x times 4 is 4x. Then take the opposite sign. And then the last term of your second factor is just the square of the second, right? So square of 4 is 16. Okay? So that's the factor of the sum of this, the sum of two cubes, x cubed plus 64. Right? Okay. Now, since we're going to find all the zeros, we know x plus 4 is a real zero. We can solve for that x, right? X equals -4. But we have to factor out this so that we can find all the three zeros because this is cubic, right? So can we factor out x squared minus 4x plus 16? Can we think of two numbers that multiplies to positive 16 and the sum is -4? If we can, then it's factorable. If we can't, it's not factorable, right? So can we? 4 times 4 is 16, but 4 plus 4 is 8. It's not -4. If we can do -4, no, -2 and -8, the sum is -10, so it cannot be equal to -4. So therefore, it's not factorable. So I say not factorable. If it's not factorable, it doesn't mean that we cannot find the zeros, right? We can still find the zeros by using other methods. And again, just like what I've said, we can use quadratic formula if it's not factorable. Okay? So I can write, if we don't have space, just use another paper. So we know we can use this, right? X equals -b plus minus the square root of b squared minus 4ac all over twice a. Okay, this is your, I'm just going to write quad formula. If it's not factorable. Okay, so we're going to use this to solve for the zeros of x squared minus 4x plus 16. Okay, let's identify our a is, let me just write this down here. What is our a? 1. What is our b? -4. What is our c? 16. So x equals, I can just plug in directly, right? So if it's negative of -4, because that's our b, then that's going to be plus 4 here. And then plus minus the square root of -4 squared. So that is 16, positive 16. I just take the square of b. b is -4. And then -4 times a times c. So -4 times a, which is 1. So that's -4. Times c. So -4 times 16. Okay, -64. All over twice a. We know a is 1, so twice a is 2. Okay, and we just have to simplify. So that is 4 plus minus. What is 16 minus 64? Negative. Negative what? 48. Okay, -48, and then divided by 2. Okay? Now, how do we simplify the square root of -48? Yes, we know because of the negative sign, we will have an I, right? And how do we factor out 48? How do we simplify the square root of 48? Let me just write the I. So we know that, okay, we can do 4 plus minus the square root of 48i, right? Because of the negative in your radicand, meaning the one inside the radical symbol. So we put an I, all over 2. Okay, so how do we factor out square root of 48? We know we can find a perfect square that can divide 48, which is 16, right? So I can write this as square root of 16 times square root of 3. Right? 3 times 16 is 48. So we can take the square root of 16, which is 4, and leave the 3 inside the radical symbol. Okay, so this is going to be x equals 4 plus minus 4 square root of 3i all over 2. Make sense? Well, we can still divide both terms by 2. We can divide 4 by 2. We can divide 4 by 2. So x is equal to 4 plus minus, 4 divided by 2. You have to divide 2. And this is plus minus 2 square root of 3i. Okay, so that's going to be our second and third root, right? Because this one will take both values, 2 plus 2 square root of 3i and 2 minus 2 square root of 3i. Okay? And again, what's the third factor, the first factor? If we say that that's going to be our first factor, x plus 4. So that's x equals negative 4. So now we have the 3 roots. Okay? So we got the 3 zeros or 3 roots. Any questions on the method? Yeah. The square root of 3, no, you don't have to, because 4 square root of 3i is one term. So if you divide the 4 by 2, it's like dividing the entire thing by 2. So that will eliminate the 4 there, but 4 divided by 2 is 2. But you keep the square root of 3i. Okay?
I don't understand.
Yes.
So the first step we did to find when x equals negative 4, that was already finding the first zero?
Yes.
Yeah, I don't.
Yes. So because we use the pattern to factor the sum and difference of two cubes, and one of the factors is x plus 4, so we can find, yes, the zero, negative 4. This one counts as 2 zeros. Remember, if you have plus and minus, that counts as 2 zeros. You can write it separately, but again, your classmates asked or requested that what if we just have to put plus and minus? Would that be fine? Yes. But that's counted as 2 zeros. Okay, plus and minus. Any other question? Yeah.
Like if that x equals 2 plus or minus like 2 square root 3i, wouldn't that be 3 terms?
No. So for the 2 square root, this one, 2.
Yeah, like wouldn't that be 3 zeros instead of 2? Because you have like 2 different like.
Oh, okay. It's just considered as 2 zeros, not 3. Because, okay, let me just try to show this part. Okay. You can write this as x equals 2 minus 2 square root of 3i, and x equals 2 plus 2 square root of 3i. So this is one value. If you plug this in on Desmos, that's one value. If you plug this in on Desmos, that's another value, but it's going to give you a decimal answer. So this is 1, and this is the second root, and that's the third one. Yes, yes, because that's the entire x. That's your entire x. Yes, and this is another one. Mhm. How do I get negative 4? That is based from the first factor that we had, right? The x plus 4, and that's why we got a negative 4. Okay. Any other questions? All right. Okay, so now, what if, okay, now the thing is, what if we're given one of the factors already? So we can use the synthetic division method, right? And then reduce it to quadratic. If it's cubic, reduce it to quadratic, and from quadratic we can factor or use the quadratic formula. Okay. So we're going to find all the zeros for this. X cubed minus 4x squared minus 29x minus 24. If x minus 8 is a factor, okay? I'm just going to do 3 and 4, and then you'll do number 5 for your practice, okay? Okay, again here, we're going to use synthetic division to find all the zeros of a cubic and higher degree polynomials with middle terms. Because in our first example, it's a sum and difference of two cubes. So we don't have a middle term. But what if there is a middle term, okay? All right, so if one of the factors is x minus 8, then therefore we know that x equals 8, right? X equals 8. So if we're going to use synthetic division, we're going to use 8, right? And then just list down all the coefficients of the polynomial. That's your dividend. And then to reduce it to quadratic, right? So that's 1, negative 4, negative 29, negative 24. There's no missing term, so we don't need to put a 0, okay? So again, we have to, do you follow? Bring down the leading coefficient, which is 1, and then multiply 8 times 1 is 8, negative 4 plus 8. For those who were not here yesterday, okay, we multiply whatever's that by the number here, and then we put the product under the next column. And then we just have to add them, right? Negative 4 plus 8 is 4. And then you multiply again, 8 times 4 is 32. And we put the product on the next column. And then we add negative 29 plus 32. Yes. This is 3, yes, and multiply by 8, so that is positive 24. So the remainder is 0. And we know, because based on the factor theorem, if one of the given is a factor, then therefore the remainder must be 0, right? Okay. Make sense? Okay, so how do we write this now? We know the given is degree 3, and so the answer will be written out in degree 2, second power. Okay, so that means it's always whatever's the degree minus 1. So that means this one has an x squared, this one is x, this is your constant, and again, this is your remainder. Okay, so how do we write this now? That's p of x. I'm just going to write this as polynomial. P of x equals, and write this 1x squared or x squared, positive 4x, so plus 4x, then plus 3. So that's going to be the reduced polynomial after we divide this by x minus 8 using synthetic division. But then we have to write all the factors, and we know one of the factors x minus 8, so I'm just going to copy x minus 8 in our answer. Okay? And then, yes?
So for the first step, like what you're doing is you're just like...
You just bring down the leading coefficient.
Exactly.
Yeah.
Like, then, like, are you dividing, like, whatever you add up together by 8? Or are you multiplying?
You multiply, you do not divide. So whatever is the number at the bottom, you multiply it to the number inside this. And then whatever's the product, you put it under the next column. And then you add, and then you multiply again. Add, multiply, add, multiply.
How do you get 3?
The 3 is negative 29 plus 32. You add them, right? Negative 29 plus 32 is 3.
Oh.
Right? And then it's not division, it's
Oh,
add,
and then,
yes.
then
You multiply the 3 to the 8. Yes. Yeah. All right. So just make sure that you know the signs, right? So if it's negative and positive, you add them. Negative 29 plus 32 is positive 3. Okay. Now, can we factor x squared plus 4x plus 3? Is it factorable? Yes. So can you think of two numbers that multiplies to 3 that adds up to 4? 3 and 1. Yes. So I can write this as p of x equals x plus 3, x plus 1, right? And then you copy x minus 8, okay? So these are all the 3 factors, and from the 3 factors, we can write the zeros. We should have 3 zeros, and all of the zeros are real, okay? So I can just say, okay, x plus 3 equals 0, x plus 1 equals 0, and x minus 8 equals 0. So x equals negative 3, x equals negative 1, and x equals 8. So these are our 3 zeros or roots. Okay. Any question for number 3?
Yeah, can you just leave it first?
Sure. Yeah.
Someone's asking if you could present.
Yeah. Sure. All right, I'll give you time, and then we'll work on number 4 for the last example.
So wait, why'd you split the 3 and 1 again?
This 3 because we need to have all the factors. Because from the factors, we need to solve for the zeros, right?
Why
So-
would you split the... Why would...
Because x squared plus 4x plus 3 is factorable. And we think of, so in this type of polynomial, if it's a trinomial and it's factorable, you can just think of two numbers and multiplies to 3 and adds up to 4. So that's why we know it's 3 times 1. So we do x plus 3, x plus 1. Make sure you know how to factor. Okay? That should be this.
Why wouldn't we split the 4x?
Okay. All right, remember, yes, we can do that, Rowan. But remember, we can only do that specifically when the leading coefficient is more than 1. Remember, if it's like 2x squared plus something, then we can split the middle term so that we can have it as 4 terms and we can do the grouping. Right? But we can also do that here, but it's going to take a long process. But again, if the leading coefficient is just 1, you can just simply do that. Okay? Yeah. How do we know to determine the zeros, expected number of zeros? Based from the degree. So if the degree is 3, because the highest power is 3, then you're expected to have 3 zeros. Based on the fundamental theorem of algebra, right? Whatever is the degree, that's exactly the number of zeros that you will have in your polynomial. So for example, if you have degree 4, just like in number 4, Therefore, you should have 4 total zeros, right? So for number 4, we're expected to have 4 because the polynomial is in degree 4. Make sense? Okay. All right, so for number 4, we're going to find all the zeros for 8x to the 4th plus 24x cubed minus 27x minus 81 if x is equal to negative 3 is a root, right? So since you're already given the 0 or the root, we don't have to switch the sign, right? We know that x equals negative 3, and then so we can use the negative 3 and use synthetic division, okay? So negative 3, and then list down all the zeros of the given. Now, is there a missing term in the polynomial?
Yeah.
Yes. What is the missing term? The x squared is missing, right? And we can check because we know this is degree 4 and we should write out 5 numbers, right? So that is 8, that is 24, and then 0 because x squared is missing, negative 27, and then negative 81. Okay? And then we can use the synthetic division now. Bring down the leading coefficient, which is 8. And then multiply that to this. So negative 3 times 8 is negative 24. And then 24 plus negative 24 is 0. And then negative 3 times 0 is 0. And 0 plus 0 is 0. And negative 3 times 0 is 0. Negative 27 plus 0 is negative 27. And then negative 3 times negative 27 is positive 81. And of course, negative 81 plus 81 is 0. Okay, so now because the given polynomial is in degree 4, the resultant polynomial will be 1 minus, right? So the resultant would be degree 3, okay? So this is degree 3. So when it's degree 3, it's just the answer. It's just degree 3 is 8x cubed, right? X squared, x constant remainder.
Why did you say it would be degree 3 instead of degree 4?
Yes, because we're dividing the given polynomial by something, by x. Let's say x plus 3 or x equals negative 3. And so the degree of the polynomial will be reduced by 1. So the resultant would be degree 3. Okay? Yes. And so I can write this as p of x, okay, for general polynomial. How do we write this now? We know x squared and x are 0, so we don't have to write that out. I'm just going to write this as 8x cubed, right, minus 27. Okay, so that's going to be your resultant polynomial. And we know I can write this as x plus 3. That's your factor. Okay? So times x plus 3. Okay? But we know 8x cubed minus 27. We should have 4 factors, right? Or 4 zeros because the degree of the polynomial is 4. So that means we can get the other 3 zeros from this 8x cubed minus 27 because we know one of them is negative 3. Okay? All right, so this is a difference of 2 cubes because 8 is a perfect cube and 27 is a perfect cube. Okay, so we can do this pattern. Okay, remember if it's a difference of 2 cubes, I can write, if this is a cubed minus b cubed, I can write this as a minus b, and then a squared plus ab plus b squared. Okay, so how do we get our a? Our a is the cube root of 8x cubed, right? A is the cube root of 8x cubed, which is what? 2x, right? And then the b is the cube root of the second term, right, which is 27, which is just 3. Okay, so
Why do we have to do the formula? Why can't we just say the cube root of a is 2? And then cube
yeah, you can do that. I'm just showing that for your classmates, but you don't have to do that part if you don't want to. Okay.
So you're not going to require that?
No.
Okay.
So that's going to be 2x minus 3. Remember, because it's the difference, so 2x minus 3. A is 2x, b is 3. And then, so for the second part, for the second factor, we just have to take the square of 2x, which is 4x squared, right? And then you multiply a and b, so that's 2x times 3. But you take the opposite sign, so if it's negative, this is going to be positive. So this is plus 6x, right? 2x times 3. And then the last term in the second factor is just the square of this 3 here. It's always going to be positive because negative 3 times negative 3 is positive 9. Okay. All right. So that's going to be the factors. But then again, in the final answer, we're going to bring down the x plus 3, okay? As our final, for the final factors. Okay. Now, can we factor 4x squared plus 6x plus 9? Is it factorable? Okay, so take note that we have the leading coefficient is greater than 1. It's 4. So we have to consider that. So, Rowan, that's the answer to your question. So if you want to create a 4-term polynomial, you can do 4 times 9, which is 36. And think of two numbers that multiplies to 36 that equals to 6. And we can split this into 2. We can do that. But is there a number that multiplies to two numbers that multiplies to 36? And the sum is 6. 36, the sum is 6. 6 times 6 is 12. 6 plus 6 is 12. 6 times 6 is 36. And then what else? 36? No, not possible. So if it's not possible, we can use the quadratic form. Again, so that means if we're going to use the quadratic formula, the answers will be complex. Okay? All right, so I'm just going to leave that there. We just need to factor out 4x squared plus 6 and plus 9 using quad formula. Okay? So, quadratic formula. That's going to be your x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, and we just have to identify our a, b, and c. So your a is 4, your b is 6, and your c is 9. So that we can plug it in here. Okay, so negative b, so that's negative 6 plus minus the square root of 6 squared is 36. Okay, b squared, 6 squared, 36, minus 4 times a. So we know a is 4, so 4 times 4 is 16. So that's negative 16 times 9. Put down the calculator, please. Negative 16. Negative 16 times 9. Okay. 144. Okay. All over twice the a. I just plug it in directly because it's going to be longer if we have to plug in each one by one, right? Okay. So, all right. So that's going to be negative 6 plus minus. What is 36 minus 144? Negative 108, okay, all over 8. Okay, so just like what we did in our previous example, then we can just have this a square root of 108i, and we can find a factor of 108 that is a perfect square, okay? So I can just write this as x equals negative 6 plus minus the square root of 108i all over 8. Okay, so think of two numbers that multiplies or that can factor out 108. That's a perfect square. Think of one number. 100 factors, so meaning that can divide 108. Divide. 9 and what? If you say 100, 100 times something will not equal to 108. 100 plus 8 is 108. 9 and 12. 9 and 12 is 108. Yes. And then 9 is a perfect square. Yes. But can we go higher? Because 12 is because we can take 4 from 12. Can we do 16 instead of 9? Yes. So 16 times what? Oh, 16, 36? 36 and 3. Can we do 36 and 3? Yes, because 36 is a perfect square. Yes. So we're trying to think of a number, okay? The largest number that's a perfect square that can divide 108. We can use 9, yes. But if you use 9, we can still factor out the other number, which is 12. So we have to use a bigger number, 36, yes. So I can write this as square root of 36 times square root of 3. Right? 36 times 3 is 108. And we know square root of 36, that's a perfect square, so that's 6. So I can write this as -6 plus minus 6 square root of 3 I all over 8. Okay? And then we can simplify. We can simplify this as what? So -6 over 8, we just have to reduce it to lowest form. So that is -3 over 4. Okay, so I'm just going to write -3 plus minus 3 square root of 3 I all over 4. Okay, so that's going to be the simplified version of this complex root. And that's already taking 2 roots, right? Because of the plus and minus. Okay, and again, we just need the other 2 roots. We know one of them is already what? Yeah, x equals 3 because that's from the original one. X equals -3. Okay, I'm just going to write x equals -3 from the x plus 3. And then we need one more, and that one more is from this, right? 2x minus 3. So again, if we solve for x there, if we solve for x, what's the value of x? If it's 2x minus 3, that is 2x minus 3 equals 0. 2x equals 3. So x equals 3 halves or 1.5. And so that's going to be your 4th one. So that means you have the 4 zeros, and we're done. Okay, so we got 4 zeros or roots.